given this piecewise function, we want to sketch the graph, and then we want to determine where the function is continuous and if there are any discontinuities to state what kind it is. So this is a piecewise function. There's actually 3 different pieces to this function here. Alright, so this is going to hopefully not get a little bit too messy here, but let's do this on the side here, okay, on the right side. Okay, let's draw a couple hash marks here on each side, and we'll see what the sketch is going to look like here. Okay. Now, of course, when we look at the domains here, right, we're sort of going in order. Okay, so for all values of x that are less than -2, okay, the graph is going to be the graph of negative x squared. Okay, so wait a minute. What does the graph of negative x squared look like? We know that that's an upside down u. Right? We're going to look at little something like this, right? Okay, so now what some students do is they like to draw the whole graph, right, and then just delete or erase the part that you don't need. Okay, so I know that I'm only going to need the graph, right, the negative x squared, which is the upside down u, for values of x that are less than -2. So here's -2. I know that when I plug in -2, I get -4 here. Okay, so actually my graph is going to look a little something like this, right? We're going to have a little upside down u, okay, going down this way. Okay, but we'll only take it from this part. Notice I put a closed circle here because of the less than or equal to sign, right? All right, so the next part of the graph is going to be the line, 4x plus 1. Okay, 4x plus 1, that's the line. I know the y-intercept is 1. I know the slope is 4, so we're going to be a pretty steep line that looks like this, right? It's going to be sort of steep. But I'm only going to take that line for values of x between -2 and 0. So when I plug in -2 here, notice I actually get -7, right? So that's going to be down here for -2. And I'm going to put an open circle there for that. And then when x is equal to 0, when I plug in a 0 here, notice I get a 1 here. Once again, I'm going to put an open circle there. And I'm just going to draw my line that goes from there to there. Okay. And then lastly, radical x plus 1. Okay, that's a radical function that's shifted to the left 1 unit. Okay. But I'm only going to take this for value of x that is greater than or equal to 0. So I'm going to, from here, I'm going to just draw that little slightly curved, right? Not drawing exactly the scale, but I should circle that in, right? Now notice what the domain of this function is, right? The domain of f of x is -infinity to infinity, actually, right? Every single point is accounted for. Okay? Everything less than -2, right? And don't be fooled by the graph. Yes, it's going down, but it's also going to the left as well, right? Slowly but surely. And then at -2, yeah, that graph is accounted for. At 0 as well. Okay, and of course, for every value of x that is greater than or equal to 0. Okay? So this is the graph. Let's see. Are there any discontinuities? And there's one here, right? It's this one right here. Okay, what kind of discontinuity is this? Okay, so at x equals -2, okay, we call this a jump discontinuity. Okay, it's not removable, right? It's not like a hole, okay, but this would be a jump discontinuity. Okay. Now, this is not a removable continuity because actually it's a closed circle, right? Okay. So there's only one point here where our graph is not continuous. It's at -2. So where is the graph continuous then? Well, it's going to be continuous everywhere else. So -infinity to -2, union -2 to infinity.